Alright, hello again, and this time we're going to be doing a micro lecture on how do you tell something is accelerating from a photo. So we're going to be looking at those diagrams or photos where it's a snapshot, kind of like this one, of the same thing over and over again. Usually we assume that the time in between snapshots is the same, and that's what we'll be working on in these. In this case, you need 3 bullet points worth of notes, a 1 to 2 sentence summary, and the follow-up questions on Google Form for full credit. So our objective today is describe evidence of acceleration in pictures. How do we know if something is accelerating? Just based on a picture, like these two pictures, how do we know that one of these snails is accelerating and the other isn't? Well, the answer is the spacing. So if the spacing is staying the same, we know it's going at constant speed. But if the spacing is changing, then we know that the speed, and or therefore velocity, is changing. So that spacing between the snapshots tells us the average speed in those span of time between those snapshots, and therefore we can begin to piece together whether or not something is likely accelerating. So let's look at 3 different scenarios. First scenario is what happens if the spacing is the same. So in this case, we've got a snail. It's going along, and each second we can see a picture is taken, and the spacing between those pictures stays the same. Based on that, we actually know that the velocity is staying the same, or the speed in this case, and velocity since it's the same direction, but it's staying the same. If the velocity is not changing, in other words, it's staying the same, then there is no acceleration. Acceleration is change in velocity per unit time, or divided by time. So in this case, the acceleration is 0, and the velocity is staying the exact same all the way throughout. If instead we look at, let's say, increasing spacing, so this snail is increasing the spacing between each snapshot, what we know is he's moving faster in this section than he is in this section right here. And the reason we know that is because literally he's gone further by the time the next photo is taken. So what that means is we've got an acceleration happening. He's picking up speed. So anytime he's picking up speed, we know the acceleration is in the same direction as the velocity. So if his velocity is this here, and a little bit bigger there, and a little bit bigger there, then all of a sudden we get to this idea that the acceleration must be in the same direction because it's adding to the velocity, or making it bigger and bigger and bigger. We can also look at a third scenario where the spacing is decreasing. In this case, we have a snail that is literally moving slower as time goes on. We know this because the spacing is decreasing, and therefore we know it's accelerating. It's just its acceleration is going to be in the opposite direction of its movement. So if it's moving this way, but the acceleration is in the opposite direction, then that means this velocity vector gets a little bit smaller. So he's got less velocity, and a little bit less by the time he gets here. So anytime the spacing is decreasing, the acceleration is in the opposite direction of the velocity, or of the movement. So to recap, same spacing means that there is no acceleration. Increasing spacing means the acceleration and the velocity are in the same direction. And decreasing spacing means the acceleration and the velocity are in opposite directions. That's it for this one. 3 bullet points worth of notes, a 1 to 2 sentence summary, and do your follow-up questions.